Okay, hi everyone, I'm Sean, this is Tony. We'll talk about our project 1786 Pell, which is a multi-agent teaching assistant for EC 1786. In university courses, limited instructor availability often leads to delayed feedback and there's a lack of personalized guidance. So 1786 Pell addresses this issue by simulating a real teaching team that's always available to provide immediate and personalized help for this course. We have 5 agentic components. The professor orchestrates requests and routes them appropriately. The teaching assistant answers questions related to course content and policies. And assignment grader consists of evaluator and feedback generator. Together, they evaluate the assignment solutions and provide structured feedback. The Menti agent simulates a curious student, and it asks users learning questions and assesses their answers. Our data sources include lecture slides, notes, and recordings, which serve as the core knowledge base of the course. We integrate course policies and measure guidelines into a teaching assistant, and we also use grading data for assignment evaluation.
Moving to a diagram, this shows how the agents interact with each other within our system. On the left, students' input flow first to the prof agent. The prof agent does not answer any question itself. Instead, it simply decides which specialist agent should handle the request. The teaching assistant agent has access to course content rack, which contains lecture recording, lecture notes, and course policies. The evaluator has access to another rack, which is focused on grading. It includes assignment materials, past student solutions, and TA feedback. OD agent in the middle has access to a shared knowledge base, which stores the overall performance of the students and the progress. Next, I will show a demo of our system in action. To begin the demo, I ask a fairly open-ended question from the course, which is describe attention mechanism in transformers. As we read through the response, we can see some sentences ended with square bracket references. Each of these references point directly to one piece of our course content. If a reference is from a lecture recording, the system will even provide a link to the exact timestamp of that video, so the student can jump straight to the exact moment instead of searching through the whole lecture.
The self-attention, which is where most discussions, in my view, completely wrong discussions.
Next, I move on to a mock assignment style question. For example, what are KQV in transformer? Our answer to that is there are matrices that involves in attention calculations. This question will trigger the evaluator and feedback agent. Then we'll compare our answer with assignment materials, then generates feedbacks. At the end, it also gives a grade like a real assignment, so the student knows how well they did on these questions. Behind the scene, a short summary of students' weakness is being written into the share log. So then if we ask something like, give me some learning questions, this question will be sent to Menti. And in the terminal, we can see the actual entry log visible to the Menti agents. Based on these summaries, the Menti agent is able to generate a set of part-text questions for the student. These questions are personalized to the student instead of being generic. Then if we send back our answer to that, the Menti will switch to evaluation mode, which gives a brief explanation to each answers, and record the key performance of the student to the share log that will help other agents adapt their response to the student's level in the future.
We have 3 success metrics: accuracy, measuring the correct alignment with course materials; policy compliance, checking adherence to course policy and guidelines; and continuity, which is ability to follow students' learning pace. We evaluate the first 2 with a custom question set and last one through observation. The system performs well quantitatively. It scores 100% on both accuracy and policy compliance. For continuity, it stays coherent for about 80% of the time. This is strong considering the turn-based long conversations. Importantly, comparing to our baseline model, which is a single agent system with access to RAG and memory, our multi-agent system performs much better on the continuity metric. We also have some interesting qualitative behavior. We had a key issue in assignment grading. If I ask it to grade my answer to assignment 1, question 1.2, for example, and provide an answer to a completely different question, it's going to mark it as correct. This is because the retrieval query uses the entire user's message. The answer takes up a large portion of the input, thus dominating the retrieval query embedding. So the retriever does the matching based on answer similarity rather than matching with the correct assignment ID and question ID. So most of the overall, our system performed as expected, and it's doing a great job on input related to course material and policy. This makes sense because given the rack setup with proper indexing and we're using clean lecture notes and recording transcript, what surprised us was the assignment grader failure. And for future work, we could improve the assignment grading pipeline by separating the retrieval for question and the answer, thus preventing the large answer portion from dominating the query embedding. Thank you.